Assalamualaikum. Good afternoon. Can you hear me?
Alaikum salam, Doctor.
Okay, so we continue. Okay, our lecture by referring to this set. Okay, so let me remind you, this is class. Okay, so you have two transfer functions, which is G1 and G2. Okay. And G2. Can you see what I write?
Yes, sir.
0.7 plus S plus 1, then S cubic plus 3S squared plus 5S. Okay. So two different transfer functions, which is G1 and G2, the open loop transfer functions. So first thing first is we try to find the roots here. Okay. So the roots is 0, minus 3, plus minus J6, and then this one. The zeros value is minus 1.1, okay, and minus 12.24, and the open loop pulse for G2 is 0, minus 1.5 plus minus G 1.66. Okay, and then after that you just plot it. Okay, we draw the S-plane and locate the open loop poles. Okay. J6. Okay. And then the second one. Okay, so locate the zeros and the poles, which is minus 1.1 and minus 12.4. Okay, zeros, eh? And the poles is zeros. Okay, and minus 1.5 plus J 1.66, more or less is over here. Okay, and then draw the locus. Okay, for this one we have a 3 open loop poles, so no zeros. So 3 root locus ended at infinity. Okay. And then for the second one, which is G2. Okay. So G2 is this one, start from poles ended at zeros, one path. And then we have something like this, goes down here. And something like this go out here, ended at infinity. Okay. The sketch of the root locus. Okay. And the question asks you, with the help of the okay, determine the closed loop poles for G1 and G2 when K is equal to 40 and give your command. So if K is equal to 40, okay, so from G1, so the closed loop T1 is 40 s cubic plus 6s squared plus 45s plus 40. Okay. When we apply closed loop transfer functions, I hope everybody knows how to do it. It is G1 1 plus G1. Okay. And then from G2, closed loop transfer functions is T2, which is equal to 3s squared plus 40s plus 40 s cubic plus 6s squared plus 45s plus 40. Okay. So what can we comment based on the closed loop transfer functions T1 and T2? What can you comment? Hasif, any comment? Your observations on T1 and T2? Hasif dah datang. Ni. Ni.
Ni Azim ke doktor?
Ni Muhammad.
Dia pergi tandas.
Tandas. Wan. Wan Ali ni. What is your observations? Ni. So the first observation is
characteristic equation.
Have the same characteristic equations. Okay. That is observation number 1. Number 2. Nur Aina Wahida. Buat sikit Aina suara. So if the characteristic equation is the same, so automatically the closed loop poles
at the same spot.
Same as well. Kan? IE minus 1 minus 2.5 plus minus J 5.8 by taking the roots of this. Okay, roots of this. Then number 3, agree?
I think both have no gain. No gain.
Ada again 40 tu. So tengok ada order. Both are third order system. Kan? Okay. And then what else? What else? This one is T1 poles, no zeros. This one is poles and zeros. Am I right? Exists. Okay. So that is the observation based on the comment lah yang dia minta. Ask for here the comment given the system. Sorry, give your comments. So settle this one, and then the second one, given a feedback system shown in the figure Q1B, based on the new dominant pole shown on the root locus, figure Q1C, determine the PD controller for the system. Okay, GPD KSX, given that the system need to operate at zeta 0.59 and 10%. So I already give you the value last 2 days. So what is the value of the dominant pole from the graph? Which is minus 6.99 plus J 9.56. Okay. Okay, so right. B. So G3 is given by the open loop. Okay. And given the ping ratio 0.59, which is correspond to the overshoots of 10%. Okay. So this zeta is we get the angle, okay, which is equal to berapa ni? Safwan, can you help me? 0.59 inverse cos.
$53.84.
53.84 degrees. So come back to the questions here. We want to find the old dominant poles. This one is the new one. So to find the old dominant pole, we have to draw the zeta line. And this is the theta. Theta tadi berapa? Safwan? 50? 53.84. Kan? So this is the old dominant pole. Okay. Which is from the graph is minus 1.75 plus G 2.39. Okay, that is the based on the zeta 0.59. But our target is for new dominant pole, which is given as from the graph, i.e. from the graph minus 6.99 plus J 9.56. So we have to use the old and the new one, TS old, which is the old one, 4 divided by minus 1.75, which is 2.28 second. And the new one, which is 4 divided by 6.99, which is equal to 0.57 second. So you can see that the new settling time is much faster compared to the old one, right? Betul tak? Is it correct? Is it correct, guys? So use PD to improve the transient. Okay, so find the real nu. Okay, which is 6.99, which is equal to zeta omega n, but zeta is constant at 0.59, so therefore omega n nu is 6.99 divided by 0.59 will give you 11.84 radian per second. Okay, and the imaginary nu, okay, is omega n 1 minus zeta square. So we already know the omega n nu and zeta, so it is already from the graph given, which is J 9.55. Okay. So what next? What next? What is the next step? Ni,
Yeah, bro.
next step. Go for it.
Saya baru datang. Saya tak pasti.
Kiong, what is the next step? Is to find the locations of zeros for PD controller. Ni, baca balik.
To find the next step is to find the location of zeros for the PD controller.
So you draw lah. The new dominant pole, which is here, minus 6.99 plus J 9.56. Okay, and the poles are minus 1, minus 3, and minus 15. So where are we going to put the zeros? Any locations? Okay. Okay, here. Let's say we put here. Okay. Zeros. Okay, zeros compensator controller. Right? And then find the angle. Okay. Find the angle, which is theta 1, theta 2, theta controller, theta C, and theta 3. Okay. Ivan, can you give me theta 1, please? Ivan Tan?
Yes, doctor.
Yeah, theta 1, please. Chong Juan, theta 2. Chong Juan, theta 2. Danson Pao, theta 3.
One 180 degree.
Sorry, Ivan, 100.
180 degree minus tangent
No, no, no.
minus shift minus inverse tangent 6.99 over 9.56.
Okay, so 11.3 degrees. Okay. 104.7 degrees. We will follow the diagram, and 81 degrees. So this total will give you theta P, which is poles. Okay. And theta C is unknown. So theta C is summations of theta P minus 180 darjah. So theta C is 101.7 degrees. Okay. So your locations of zeros is about here. Okay, this one is minus 6.99, and this one is 9.56, 90 degrees. Okay, and 117 is over here, and find the alpha. Okay, with this distance is x. Okay. So alpha is equal to 180 degrees minus 117 degrees, so 60 degrees. So tangent 60 degrees is equal to 9.56 divided by x. Okay. So what is x actually? X is 6.99 minus z. Okay. So if you simplify, you will get 4.8711 minus 6.99. So the zeros is positive 2.12, which is on the right half plane. Okay. And then you calculate we know that the GPD is equal to K S plus Z. So we already know the Z value, which is here is because it's on the right half plane, so it is minus 2.12. But this one we don't know, so we have to calculate for the gain K using the magnitude criteria. Okay. S plus 2.12. So substitute S with the new dominant pole plus J 9.56. Okay. So you will get K 135.81. And then GPD is equal to K S plus Z, okay, which is 138.81 S minus 2.12 because it's on the right hand side. Sorry, it's not, it's minus 2.12. So supposed to be positive. Okay. So it's positive value. Okay. Okay, it's positive value 2.12. And we know that Kp over Kd is equal to 2.12. That's why Kd, okay, is equal to 138.81, and Kp is equal to 287.9. So this is the P controller, which is we have to design until at this point. Okay. Any questions? So if no questions, we move to the front questions, which is here, 2013 and 14. Kon Yawen. Miss Kon, can you write? Can you read the questions?
A unity feedback system in figure Q1 has an open loop transfer function GSK over s plus 5 s squared plus 2s plus 2. Draw the root locus of the system in showing all the steps.
Okay, so this one is 2013. The old sessions now, eh? During that time, you have to draw using a graph paper. Okay, so for this purpose, so I just mentioned sketch, freehand draw. Okay, so freehand draw for the plotting, right? So this is the open loop transfer functions. Okay, so the open loop poles are what? -5 and -1 plus minus J1, correct? Okay, and then you plot it here. This is the graph they given during the test 2013, long time ago. Okay, so -5 is the locate which is here, and -1 plus J1 over here. Okay, so no zeros. Right, so from here you already know there is no zeros. So definitely we have a 3 root locus path. Why? Because we have a 3 open loop poles. Okay, and 3 RL path ended at infinity. Okay, so something like this goes up, something like this goes down, and ended at infinity. So that is the sketch. Okay, so you can calculate the asymptote. Okay, just give you the asymptotes. 2013-14. One. Okay. 3 root locus ended at infinity. Okay, so theta E, which is using the formula 2k plus 180 degrees divided by 3 poles. So you have a 60 degrees, 180 degrees, and 300 degrees for the angle of asymptote, and then the cross sections of the asymptote line is by using the formula, the value of the zeros, which is -1 plus J1, okay, plus -1 plus minus J1. -5, no zeros, okay, and the numbers of poles is 3 minus 0. So this one cancel out. So you get the sigma A asymptote intersections is at the real axis -7/3. Okay. So what is the intersection of RL and imaginary axis? What is the steps to find this? Natra Hassan?
Find characteristic equation.
Huh?
Find characteristic equation first.
The
Characteristic equation.
closed loop transfer function from open loop transfer function, kan? Then find the characteristic equations, kan? Right. So what is the characteristic equations? That's right.
S plus 5.
Mhm.
S in bracket S power of 2 plus 2S plus 2.
Okay. S plus 5, S square plus 2S plus 2 plus K. Plus K.
Yeah. Equal to 0.
Jadi, this one is the characteristic equation. S square plus 2S plus 2 plus K equal to 0. Simplify. S cubic plus 7S square plus 12S plus 10 plus K equal to 0. Then goes to the Ruth-Lewis table. Okay. S cubic, S power of 1, S power of 0. Okay. 1, 7, 12, 10 plus K. Okay. So what is here? Asnawi? Asnawi? Tak tahu. Wenjin?
That's okay.
What
Negative
is-
determinants of 1, 12, 7, 10 plus k divided by 7.
Okay. So it will be 10 plus K. Correct. Correct. Ini salah ni. Okay. So it's not 10 plus K, sorry. So this one is K minus 74 over 7. Imagine. Right. 10 plus K. Okay. So the first column, which is here, according to the theory, must greater than 0 to find the range of stability. So 1 is already greater than 0. This one is already greater than 0. So this one greater than 0, greater than 0. So K minus 74 divided by 7 greater than 0. So K is, what is the value of K? What is the value of K? K 74. Okay. 10 plus K greater than 0. So K is greater than minus 10. Okay. Right. So the range of stability is between 0 and 74. Okay. Just K. So find the even equations from the Ruth-Lewis, okay, which is 7S square, this one. Seven S square plus 10 plus K. Equal to 0. So this one is 74. Then it's simplified. So you will get S is equal to square root minus 12, which is J 3.46. Okay, that is the intersections where J omega J 3.46. So the omega n is 3.46 radian per second. Okay.
Sorry, doctor. Omega N or omega D?
Omega N.
Omega N. Omega N. Not.
Omega D. Sorry, omega D.
Okay. Thank you.
Because it's on the imaginary. Sorry, yeah. Imaginary exists. Right, and then you can calculate for the others as well, properties. So let's go to the question number 2, which is here. Sharif.
Yes, okay.
Baca question number 2.
Question 2. Figure Q2 shows the root locus of an unknown control system.
Unknown.
A.
Unknown maknanya open loop transfer function is not given. Okay. Continue.
So question A, obtain the open loop transfer function of the system. B, find the value of gain that will make the system marginally stable. And C, if the system is limited to operate between critically damped to 4.32% overshoot, find the ratio for K for this operation.
Thank you. Then end of the question they give formula. So use that formula. You don't have to memorize. Okay, so what is the open loop transfer functions? Liana Camelia?
Yes, Prof.
Open loop transfer functions from the given root locus. Tak tahu. Safwana? Nur Safwana.
Safwana pergi tandas betul?
Di tandas pula. Nur Hazika Syazwina.
One plus minus J1.
Atas dulu lah, zeros. Gimana, Bah? S minus 1 plus J1 S minus 1 minus J1. Kan? Here S
plus 4.
S plus 2. So this is the open loop transfer function. We read from the given locus. So we simplify. Okay, we simplify GS. So it become K S square minus 2S plus 2 divided by S plus 2 S plus 4. Then find the closed loop transfer functions because we want to find the dia punya cross sections ini. Okay. We can read from there. Okay, we can read. Can somebody read for me? What is the omega D value? Sammy, can you read for me? Not more than 3. I think is
2.8 or 2.9.
This one is 2 or 3. This one is 2, right, brother?
Sorry, then 1.8.
0.8.
1.8.
Okay. Plus J 1.8. So this is by observations. Okay. So we have to prove it using the calculations by find the closed loop transfer functions. Okay. Okay. So S square 1 plus k minus 6 minus 2k 8 plus 2k equal to 0. Okay. So Ruth-Lewis table is S square plus S power of 1 plus power of 0. So 1 plus k, 6 minus 2k, 8 plus 2k, and 0. So continue the fill up. So this one will be 8 plus 2k. So look at the first column. So each of it must greater than 0. Okay. So 6 minus 2k greater than 0, simplified. So you get k less than 3. 8 plus 2k greater than 0, simplified. So you will get k minus 4 greater than minus 4. So the range of k will be range of k 1 plus k, 6 2 minus k, 1 plus k. One plus k greater than 0. So k is greater than minus 1. Okay, so the range of k is 0, k, and 3. Okay. So this is the k critical. Is equals to 3. Okay. So what is the omega critical? So we have to find the event equation from Ruth-Lewis, which is 1 plus k s square plus 8 plus 2k 0. Okay. So enter this value as 3. Simplified, so you get 4s squared plus 14 equal to 0. So s is equal to minus 7 over 4, which is plus minus j 1.87. Semi, you said 1.88, so more or less.
Yes, close value.
Proof by observations and by calculations. And Ismail,
Yes, doctor.
What is the gain k at here?
The gain, we insert the value, the point,
No need,
in the magnitude criteria.
No. Yeah.
Oh, 3.
Salasa is already proof from the roof. You don't no need to insert like the formula. No need. Okay.
All right. Thank you.
And then given overshoot from the questions, 4.32%. So what is the damping ratio? Using the formula, okay, formula which is given, this one, okay, so use your calculator, use that. You must bring your calculator during a test. So zeta is about 1. Zeta is equal to 1. So critically damped. Actually, you don't have to use the formula. Critically damped, meaning that it is equal to 1. Okay. So okay, zeta equal to 1. Okay, and then overshoot almost 0. Okay, the pole location is at 2.18 at that particular point, minus 2.8, which is over here. Sini. Okay, and zeta equal to 1. Okay. So students sometimes they are confusing between gain and damping ratio. So let me explain. So this is j omega, the axis and real axis. So here, okay, k is equal to 3, but zeta is equal to 0. But here, minus 2.8, okay, which will give you the k value roughly about 0.062, but zeta equal to 1, damping ratio. So damping ratio and gain is not the same. So at this axis, zeta equal to 1. At this axis, zeta equal to 0. So how about this one? The shaded one. The shaded one is the zeta is between 0 and 1. Okay. How about this one? On the right half plane. On the right half plane, okay, zeta is less than 0, negative. Okay, so negative meaning unstable lah. Right, so we already know the pole location there, which is from the graph, from the Locus graph. So then we insert inside the magnitude criteria to find the gain, s plus 2, s plus 4, divided by s square minus 2s plus 2. S is equal to minus 2.8. So that gain is 0.0623. Okay, where zeta is equal to 1. Okay, the damping ratio is critical. Okay. Finish. Okay. So finish. Halas. Alhamdulillah, halas. 12:49. Any question, guys? Any question? Chua Lei Yong, any question?
No, Doctor.
No, Matthew, any question? Understood? Matthew tak datang. Nur Safwana, ada soalan?
Ada, Doktor.
Dia, pause. Any question, Patrick? Any question?
Doctor, so our test one will cover all this question.
Yeah, from root locus until PD controller. PD and PI controller. PID not included. P controller, PI controller, and PD controller. Any question? Ni. Ada soalan? Tak ada soalan Okay, kalau tak ada soalan, I see you next Monday. Okay. Saya dekat. Okay.